Now, weak acids and weak bases are another thing. Weak acids and weak bases are another thing. This assumption, we can no longer make the assumption that H plus is equal to their initial HA concentration. We're going to make a situation that we're going to figure this out. We have to use the K expression to find the H plus concentration. This would be our K expression, but we can often abbreviate it in a couple short steps, especially on big long tests. We can probably make this assumption that we're going to find H plus. H plus is going to be equal to A minus. So rearranging that, you have X squared over HA. For a weak acid, usually H plus is equal to the square root of our Ka times my initial concentration of acid. That's true for just about most weak acids and weak bases. OH minus will be Kb, the initial concentration of base. Now I'm going to use acetic acid because I remember the Ka like the back of my hand. Ka for acetic acid is 1.8 times 10 to the negative fifth. If we have initial concentration of 0.135, what would be our H plus and what would be our pH? Well, to do that, we're going to say the square root of our 1.8 times 10 to the negative fifth times our 0.135. So that's going to give us our H plus. 5 and then times 0.135. So our initial concentration of acid is going to be 0.0015. We'll say 156. And then the negative log of that would be a pH of 2.81. 2.81. That's how treat almost any acid and base, weak acid and weak base. We are going to use that square root to go over that. Now, with a buffer is when we have a weak acid mixed with its conjugate weak base. Weak acid mixed with its conjugate weak base. So, for example, using our acetic acid, it's just a rearrangement of our K expression. The rearrangement of our K expression. So instead of 0.0135 molar acetic, we also have, say, 0.221 molar of the sodium acetate. So rearranging our Ka expression to solve for H plus, you would get that Ka times HA over A minus. Oftentimes, this is just abbreviated as pH equals pKa plus log of A minus over HA, the Henderson-Hasselbalch equation. But don't feel like you have to memorize or learn this equation at all. It is just a rearrangement. You take the negative log to both sides of this, and you get the Henderson-Hasselbalch. You're just separating out the terms. So don't feel like you have to know that equation. Let's just solve for H plus using this. Let's make it easier on ourselves. 1.8 times 10 to the negative fifth times 0.135. Now, instead of square rooting this, I'm dividing by my A minus, which is 0.221. So to figure out how much acid do I have? 5 times 0.135 divided by 0.221. You would get a really small number, which is 0.00001095. I don't feel like rounding that. Then taking the negative log of that, you would get the pH. So my buffer would have a pH of 4.96. So just by adding that conjugate base, we jump from 2.81 to 4.96. And that's how you treat buffers. Buffers, all this comes down to setting up your Ka expression. If you understand what you're doing with the Ka, there's not really a equation you learn. It's you set up your Ka, you solve for your H plus. If we don't know either, they're X and X. If we only don't know this, then this is the only one we need to solve for. We're just rearranging to solve for the H plus. And that's how you treat buffers.